Sir, please share your screen, sir. I made you as a presenter.
Ma'am, is my voice audible?
Yes, ma'am, it's fine. Good.
Okay, so welcome you all. I just love to introduce Arun Ponnaswamy. Arun Ponnaswamy is currently working as a technical lead at Multicore Ware India Private Limited, Coimbatore. He holds a bachelor's degree in electronics and communication engineering from PSG College of Technology, Coimbatore. He has a decade of experience working for several AI startups as a computer vision engineer. His areas of expertise include image classification, object detection, object tracking, human activity detection, and face recognition. His works in the field is focused on making computer vision and machine learning accessible to everyone. He is also the author of the open source Python library, CVLib. Arun has contributed hands-on workshops on computer vision at academic institutions like VIT and IIT and has delivered talks at various community meetups. He is passionate about explaining complex topics in a simple, intuitive way. So I hand over the platform to Arun Ponnaswamy. Sir, you can take over the session.
Yeah, thank you, ma'am. Thank you for the warm welcome.
Arun, sir, share your screen, sir.
Yeah.
Yeah.
Can you see my screen, ma'am?
Yes, sir, visible.
Okay. So, hello everyone. Thank you for taking the time, on a Saturday afternoon. So, I'll keep this session like brief, and I'll try to focus. I'll be focusing on computer vision in the recent Gen A era, and also we'll explore a little bit about LLM architectures. So, as you know, I mean the field is like changing a lot because of AI and the recent developments in generative AI. It is fundamentally changing the way we are interacting with any applications, or it is also like changing all the industries and the applications, how people interact with it. So I have been working like mainly in computer vision for the past almost 11 years now. I started off with traditional image processing. I was optimizing image processing pipelines for different hardwares and trying to optimize the algorithms. Then I like slowly moved into computer vision, and that was the time machine learning and deep learning was evolving. So if you look at the field, computer vision as a field, it is changing again. So the first thing was, I mean, computer vision as a field, it has been there for for a very long time. So I see it as like this is like a second revolution in computer vision. So we have this conventional computer vision that has like traditional image processing and manual feature engineering and computer vision algorithms. They are there. So the first revolution started when deep learning started to become a thing, and it was giving better results. So computer vision was mainly like it was kind of deep learning was the main algorithm used in computer vision, and it was kind of taking over. So this started around like 2000, maybe like 12, 14. So that was the time. Now, like 10 years later, now generative AI and LLM architectures, now vision language models. So these are kind of again revolutionizing the computer vision field again. Now VLMs are like becoming good at most of the computer vision tasks. So now the field is again, in the phase of changing. It is going through a changing phase. So from this perspective, I'm trying to approach this topic. So a brief introduction about myself. So I started off, as a software engineer. I consider myself as a core, software engineer. So I started off, but in an image processing team. That's how I got exposed to image processing, in the industry. Though we had courses like, digital image processing, or signal processing, you know, uh, in my college. I mean, the image processing I saw, in the industry was, at work it was different. It was mainly focusing on building, practical, production ready applications, and within that, what are the requirements and how do we optimize it. So that's how, I started off. Then I, gradually, like, when machine learning, became popular, and coming from the image processing background, I naturally, like, moved into computer vision, and I since then I've been, like, passionate about computer vision and machine learning. So yes, ma'am said, no, I'm a graduate from PhD Tech, and yeah, I consider myself as a, lifelong learner, because the field is changing. Every single day there is, new research coming out, and the way we solve problems is changing. So there is no one, like, knows everything. Or we need to keep learning, and how we need to look at how things are moving. So from this learning, I try to document some of my learnings, as a blog post or a video tutorials, and sometimes I write a newsletter, covering what's happening in this field. And other, open source work that I have done is, again, putting together this learning into a usable library or code, that people can use, and find it helpful. So yeah. So I want to start off with a general overview of AI, because there is sometimes slight confusions, or misunderstanding about what specific terms are, machine learning, deep learning. So we use this word interchangeably, like AI and ML. So I just wanted to, like, touch upon this. So AI is the, like, a high level field. So even AI as a field, it has existed, for a long time, even in the beginnings of, 1900s. But that time, the algorithms or the techniques that people were using were not, giving reliable outputs. So in a generic way, we can define AI as, we are trying to mimic, human intelligence, and trying to do stuff that needs decision making or reasoning. So we can use any type of, algorithms or methods to achieve that. So people have tried different things. So within this field, machine learning is like one subfield, or subset in this, where uh, we tried a specific set of algorithms, that is called, like, machine learning. So trying to build learning algorithms which can, look at the patterns in the training data, and trying to understand that patterns, and use that learned patterns to predict for future inputs. So this is one type of method. So that is like machine learning. So within machine learning, there are techniques which does not use neural networks. For example, SVMs, support vector machines. So they are like they come under machine learning, but they don't really use neural networks. So there are different approaches like random forests. Again, these are like traditional ML approaches. So for a very long time, people are using these kind of approaches, manually, feature engineering and everything. But so those times the results were not like very reliable to get into production, and they are not ready for a wide adoption. So then a specific type of algorithms called neural networks were developed. It was around 2012. I think that was the time ImageNet competition. So there is a competition called ImageNet. So it is like a large scale image classification challenge. So every year, people used to compete with different algorithms and trying to achieve the best accuracy possible on the data set. So around 2012, that was the time like neural network based algorithms were making huge results, and they won the competition. So that was the time it became popular. So even that time it was like smaller networks, CNNs, convolutional neural networks. But over a period, when people knew that this type of approach is working, then people trying to add more layers and trying to make the network deep, and trying to achieve as much as possible in terms of accuracy. So that's how the word deep came into picture. So it is just a fancy name. So it is still like convolutional neural networks or neural networks with just more number of layers, and the network is very deep. So so it is again a subfield within neural networks. So as I said, the field, AI as a field or machine learning, it has existed for a very long time. But we are in a very important time, in the history, because everything came together to to give to contribute this this rapid growth and learning algorithms and machines trying to learn. So one thing is like data, and the other thing is the compute power. So both of them like have come together. So if you look at the life in this century, right? We do a lot of things in the digital way. So everything we do and everything we interact becomes a data point, and it is digitally stored somewhere. So this is like a example numbers from 2020. It says like 500 hours of video is uploaded by the users. I think it was like every single day, or okay, it is every single minute. So you can think of how much data is being generated now. We are in 2025. So now we have this large amount of data, and we have also like developed algorithms that can learn from this data. Now to make sense of this data. So to make this data, we need large. I think there is some noise.
Sir, I muted them, sir. You can please proceed.
Okay, yeah. So in terms of hardware, there is also like a huge development. So for example, NVIDIA is as a company, they have been making GPUs for a long time. So initially, these GPUs were meant for display, graphical processing, and gaming. That was the like initial motive and selling point for them. So when this machine learning and deep learning was becoming a field, so naturally people are looking for what hardware can be used to better accommodate these models and this huge training data. So people like found that GPUs were good at doing parallel processing, and also like this machine learning algorithms can process. So it is the same algorithm, and which can run on multiple. For example, if it's an image data, multiple images can be like processed in parallel for this training. So people found the natural fit, and then GPUs were mainly used for this uh, model training. So now you can see NVIDIA has become a monopoly in this area. So now with data and and compute, and the field started to grow. So within AI, there are a lot of subfields. No, I'm mainly working on computer vision, which deals with images and videos, trying to understand. So computer vision is nothing but just trying to give computers the ability to do whatever our human vision system is doing. It's just that trying to understand what's going on in the scene. So camera is it just captures the image. It doesn't really understand what's in it and what's happening. So computer vision algorithms is like a brain that gives the ability to make sense of what's in it, and basically trying to help help us to act to take actions. And with respect to text, we called it natural language processing. Trying to understand text, or now the field has moved into, our focus is more into now generating text through large language models. So LLMs are kind of uh, taking over NLP. And audio processing, and speech recognition. So we had this speech recognition for a long time with assistants like Siri or even Google Assistant. The speech recognition was there even before LLMs, but now after recognizing the speech, the assistants are like much more better in understanding and trying to give back results. And we have this tabular or structured data for recommendations and forecasting. For example, the recommendations we get on Amazon or Netflix, so they are like based on the structured tabular data based on whatever people have interacted with earlier. So every click is a data, so that is stored, and based on that the algorithm tries to learn and predict what could be the next, or what users might like. So that is one area. And now generative modeling or generative networks. And now other than that, we also have reinforcement learning. So this is like different from supervised learning, that we give data and we label the data, and we let the model learn from the labeled data. So reinforcement learning is like letting the algorithm or the agent to interact with the world, and based on the feedback and the reward function, it will try to learn from the experiences, and then basically trying to optimize for the rewards. So once we have these algorithms and data and we train models, so we need to look at like where this can be deployed in production, how it will be useful to people. So these are the like main places we basically deploy models and build applications, right? So one thing is like the cloud backend server. So we send the request from a front end device. It can be like a mobile or desktop or whatever it is. So from the front end, we send the request to the backend. So we send the input. If it is an image or text, we send it to the backend, and then there it gets processed, and then the machine learning models will be in the backend, and then the processed prediction or output will be sent back to the front end. So this is like one example. For example, ChatGPT. So we basically like from the front end we send the input, and it goes to the back end, OpenAI servers, and then we get the results. So another area is edge devices. So these are like embedded devices where the models run on the device, and we get the results. So this is like it can run without connection to the backend. So it is like an on-premise, a small server or small processing unit where everything happens on the device. So like automotive industry or surveillance or CCTV. So those kind of places we try to run the models on the device because it needs the real-time inferences. And we also have mobile. So on mobile, we have now we have on-device models, which runs on the device. It can run offline, and the latency is also smaller, so it doesn't need to go to the backend every time. And the other category is in browser. So this category is like not very popular, but we can run machine learning models in the browser itself, through like JavaScript. So now it can run in the browser. It is like offline. It doesn't have to go to the backend. It can run in the browser and give us the results. So these are the like main platforms, and there is difference between each platform, and we have pros and cons for both of them. So for cloud, we need to have this backend API call over the internet, every time, and the benefit is we can access larger compute resources which are like sitting in the backend server. We need not have that in the mobile or desktop, and of course there is like possible time delay, and it needs always on connectivity. So another thing is like privacy or security concerns, because our personal data will go through the internet to someone else's server. So that is one concern. So on edge, we have on-device processing, so it doesn't have to go to the backend. But edge devices are like constrained in terms of resources, memory, and the hardware processing power. But it can be real time and it can work offline, and the data doesn't leave the device. But still, security is still a challenge because it is a smaller device, and the ability to run security protocols will be a challenge. So in this machine learning and AI field, so there are a lot of open source tools and free resources that people can use. So mainly people use TensorFlow and PyTorch in terms of for model training and experiments. With respect to computer vision, like OpenCV is one of the mainly used library, and there is also like another library called DLib. It has some computer vision algorithms implemented. And for training, and trying out things, Google Colab, is a free resource. We have access to GPUs for a particular amount of time in the free version. And we have GitHub for with a lot of code examples from people making it available open. And there is also like a lot of online blog posts and courses and platforms like Coursera or deeplearning.ai. So there are a lot of resources to look into. So one of the main shift in the way we are programming and creating software. This is kind of the machine learning intuition I would like to share. So traditionally, we write, hard-coded rules. We decide the rules and we write, if-else conditions, to process the input, and then we, generate the output. But in terms of machine learning, we don't define the rules, or it is hard to define the rules for real-world problems. For example, image classification or recognition. It is very hard to write specific if-else conditions or rules for for recognizing what is in the image or what is happening. So because instead of writing these rules and and trying and failing it, so the way we are doing with ML is we have this ML algorithms. We give it or we show it the data, and we tell the algorithm what this data and what is in it, and the algorithms are trying to learn the patterns between the data and the expected output. And then from this data, it understands and learns the patterns. Then that becomes the rules. So these rules, then we take it and use it. So we give the input, and then it goes to the rules and get the output. So now the shift is these rules are learned, and these rules are like not 100% perfect. So the it is like how how much percentage it is accurate, and we keep improving the accuracy. But this is the like main shift from the traditional programming. So if you have any questions in between, like feel free to interrupt and we can discuss. So this is like basic like image you might come across when you look about neural networks. So so this is like from the high level. So these are like each are called neurons. So these are like inspired from our human brain. So between the input, let's say if we have like three inputs, let's say three numbers, then it is like, let's say if you're expecting one output, let's say we are predicting something, it can be like a yes or no, like 0 or 1 classification, or it could be like a real-time value, like predicting what would be the value of a particular object or particular product. So these inputs will go through these hidden layers, and each so this specific network is called like fully connected layer, fully connected network, because there are other type of networks as well. So in this each neuron is connected to all the other neurons in the next layer, and how this input is getting transformed to the next layer is like through mainly like multiplications and additions, through weights and biases. So how this is getting multiplied and added, that is the value that we learn through the training process. It is like a iterative process. So initially it may start at random values, and then over a period through back propagation. So we back propagate the error, and we try to minimize the errors in the next iteration. And then this happens for until we start seeing some good predictions. So this is like the main idea of in training. So AI is like finding applications in all the industries. So initially it was AI was just in labs. Now they are like in the hands of people, and in every industry, and trying to change the way we get value in these industries. So AI in healthcare is like one area where it can have huge impact. Whether it can be like medical imaging, or finding new medicines, or in terms of monitoring or assistance. And medical files processing them is like a huge task in the healthcare industry. So now AI is also helping in terms of automated processing and automated monitoring. And there is also like personalized therapy or assistance that can be done. So I have worked for a healthcare startup previously, where we try to build an autonomous monitoring system in the healthcare facilities, where it is like an edge device, and it can continuously look at the camera feed, and it can understand what activity is being performed. And let's say if a particular patient is trying to get up from the bed, and without any assistance, and it can create uh, an, an alarm or an alert to the concerned uh, person, and they can get the notification. So these kind of monitoring we were trying to do. So this is like an edge-based IoT device. So like similarly, like how IoT is like an embedded device with an internet connection. Now IoT devices with AI models in it, they becomes AI OT, and it becomes much more intelligent and useful. So as I said, in edge computing, there are challenges, because in this small form factor, there are like limited number of CPU cores or memory and disk space. So now with AI, coming into this, edge computing, there are AI specific accelerators are also like coming into this IoT space. For example, NVIDIA Jetson devices, they have GPUs, in the small form factor, and TPUs from Google, and specific deep learning accelerator or neural processing units are coming up. So each company or manufacturers, they have specific accelerators, like Qualcomm, they have these NPUs. So then we also need to consider how much power consumption and heat dissipation. And once we deploy these models, how do we monitor the performance? So those kind of challenges are there. So now that like we kind of have a high level overview of what the field is and how things are happening. So now let's look more closer into computer vision. So in computer vision, there are a large subtasks within the field, depending upon the use case and the industry. So like some of the fundamental tasks are like image classification. So this is like identifying objects or scenes in the images. Object detection is like locating and classifying what object it is in the images. And image segmentation is like dividing or segmenting a particular object in the image. So this is like for example, in video conferences we have this background blur. So this is actually an example of image segmentation. So we segment persons in the image, and we once we segment it, we can blur what is the like other part of the segmentation. So apart from that, there are like other tasks like object tracking, image generation, pose estimation, face recognition. So there are a lot of subtasks like OCR. So this is like recognizing the text in the image, and then activity recognitions and so on. And within specific field, there are like specialized tasks like medical image analysis or surveillance, autonomous vehicles and robotics. So these might include multiple steps and multiple tasks. It can be like recognizing a particular object in an image and then do the next task. So it can be a multi-step task, and which can involve these fundamental computer vision tasks in a particular order. So when it comes to computer vision on the edge, so one thing we look at is FPS, so which is like how many frames per second it can process. So for an output to be like to be real time, so 30 frames per second is the like a real time processing speed. So if that goes below like 13 or something, we'll start to see the lag, and it will not look smooth. Then it will not be like a real time video. So to achieve this, we look at a lot of things, starting from designing the model, how many layers it can have and how deep and what is the model size and everything. So this is starting from the model architecture, and then once we train the model, we also like spend time in optimizing the model for specific hardware. For example, NVIDIA has something called TensorRT, which helps optimize the model for that specific NVIDIA hardware. And we also have like TensorFlow Lite. It can take the TensorFlow model and converts it to like optimize it for CPUs. And then we also have this language of choice. Like we still use C++ for better performance. We do, even though we do the experimentation, research and analysis in Python, when it comes to performance, we still use C++, and there is like multi-threading and all the other optimizations are there. So this is something we do a lot in my current company, Multicoreware. So currently, like I am working on a project for an automotive product, and where we do all these kind of optimization to achieve real-time performance. So main device that we are using is like NVIDIA devices, and there is also other accelerators from companies like Qualcomm and other devices. 1 second, ma'am. I'll be back. 1 second. Sorry. So within OpenCV, I mean within computer vision, the main library that people use is OpenCV. So it is like an open source computer vision library, mainly written in C++, but it has bindings for other languages as well. So it was started, as a project at Intel. So the goal was to have, open source and optimized image processing library so that people can reuse it, and it can support, real-time applications, and it has hardware accelerations for, all these devices using, OpenCL, Coda, and it is also available for, most of the platforms. So within OpenCV, there are, a lot of modules which are like focused for specific areas. So I'll not go deep into this every modules, but I'll just give an overview. So OpenCV has, different types of filters, for, denoising or, smoothing up the images. So there are different types of filters like focused for different scenarios. So mainly they are into like denoising or blurring. And for specific kind of noise, for example, if it is, white and black salt and pepper noise, a specific filter might do well on this. For example, median filter will do well or for salt and pepper noise. So there is also like Gaussian filters. So other functions in OpenCV, like these are like morphological operations and edge detections, histograms and thresholding. There are majorly used functions. Edge detections. So in general, like edges are like very important in terms of keeping the structural information. So traditionally, like we design filters or kernels, so which are like the 3x3 or 5x5, whatever the filters we usually like design it. But now, in terms of with convolutional neural networks and deep learning, so these filters are learned, from data, and not just they don't like not just detecting edges, they detect, a variety of shapes, and then as we go deep into the layers, they can recognize, specific objects in in the world, and the filters like they grow, and they can recognize a lot. So these are like traditional image processing functions, thresholding, So putting together these functions, both traditional computer vision and deep learning, we can build applications like, for example, like the document scanner that we have in our mobiles is like basically a computer vision application which puts together these areas. For example, edge detection, after that contour detection, and then transform, and then finally thresholding to give it the black and white feel. So the first step, would be to detect the edges, and then find the contours. After that, we can do the transform to make it straight, and then we can apply this thresholding to get this paper-like feel. So this is like a high-level idea. So within that, now there are more deep learning models can be used for object detection or segmentation, but this is the high-level idea. Like face detection. So this frontal face detection using R cascade classifiers. So these are the ones we used to have in handheld cameras because they were very fast and it can do like almost well in terms of detecting frontal faces. So once we detect faces, we can also like detect facial landmarks. So it might look simple, but it can have very useful applications. For example, drowsiness alert in the automotive field. If the with the landmarks and the distance between these landmarks, we can detect whether the eyelids are open or not, and how far they are being closed, how many seconds it is closed. And there is also like other fun applications like filters in Snapchats or Instagrams, and then face morphing. So those kind of applications, like it needs a serious computer vision into it. And so OpenCV also has this DNN module. So initially OpenCV did not have this deep learning support, but as the field emerged, now they have added a separate module. So OpenCV like is not used for training the models. So typically we train it using other frameworks like TensorFlow or PyTorch. But then once the model is trained, we can bring that trained weights into OpenCV and we can run inference. So for OpenCV, so of course OpenCV.org has all the official information. But other than that, other platforms, blogs like Learn OpenCV and PyImage Search, so they have a lot of hands-on blog posts. So so now like we are in this phase of generative AI era. It has seen a good rise in the recent years. Maybe it has been like maybe like 2 years since ChatGPT was launched, and there is a lot of progress. And now the companies are like shifting their focus to become AI first companies like Google. If you look at Google's annual event, Google I/O, so in 2025 it happened like in June. So most of the announcement were focused on AI, and companies are shifting their focus to become AI first, like Microsoft is reorganizing to become AI first, and AI agents are becoming more and more focused. So all of this is like because of the recent advancement in generative AI, LLMs and chatbots have become a lot more intelligent. So mainly like one is like generative AI, and then generative modeling, and then reinforcement learning with human feedback. So these are the two things that is behind tools like ChatGPT. So initially it started off with text input and text output. We interact with the models through text, and they understand, and they generate text. But now the systems have grown to include images, and even now visual intelligence is also imported into it. So now we can ask questions with an image, and we can ask it to generate, and now it understands what's in the image, and it combines it with the text. And now there is also like video generation models, just from a text prompt or some reference images, it can generate videos. With tools like Google Veo, the video generation is also like being transformed. So we have seen the basic tasks in computer vision, like image classification or object detection, segmentation. So traditionally, like we will need large labeled data.
Hello? Hello? Uncle? A white color. ಅದೇ ಸಿಲ್ವರ್ ಅದು ಸಿಲ್ವರ್.
So from the traditional way of doing it, now it is coming into generative AI era, where in terms of with vision language models, all of these tasks can be like performed with a single model. With a prompt, we can ask the model to ask questions or ask to do these type of tasks, and a single model is becoming better and doing all of these tasks. So when the generative modeling started to evolve, we had GANs, which are like generative adversarial networks. So they were the first type of model to generate realistic images. And then we also had variational autoencoders. Then after a while, diffusion models came, and they were able to create really high quality images. So it was mainly like text to image generation. We give a text prompt, and then it generates an image. Now we can ask it to complete an image, and we can ask it to change certain aspects of an image from a text, and it understands it and generates it. So now computer vision is kind of merging with, or taking the advancement in LLMs, and now they are becoming one model is trying to do everything. So now it is also like improving computer vision's ability to interpret complex visual scenes, and then it helps in synthetic data generation. It also like increased the efficiency in different applications like image editing, restoration, and image generation. So in terms of traditional image processing or computer vision, we usually like train individual models to perform a very like narrow task. For example, if it is object detection, and within object detections, what objects we want to detect. So if it is person, dog or bicycle. So for each category, we will collect data and then we will train the model. So the model trained to detect a few number of objects that can do only that. It cannot do other things. So if you want to image enhancement or image generation, it has to be a different model, and it has to uh, the amount of effort it took to train, create labels, and models. And for each, if you want to accomplish an application and which involves different tasks, we used to have multiple models, and handling these multiple models will become a bottleneck in terms of using the resources and how much time it takes. Now with generative AI and with vision language models, it is becoming more and more simpler, and the pipeline is also becoming simpler because it's just one model. But the way we are training it is different, but it is changing with respect to the one model handling all the tasks. So like we saw, like diffusion models. So they were the techniques that are being used in models like Dolly from OpenAI, and Imagen from Google, and Stable Diffusion from Stability AI. So diffusion models like are the like a recent ones, and we also have like vision transformers. So transformer is the architecture that is like the basis for all of this recent advancement. So the original paper, transformer paper, was published by Google, and and people started to work on top of it, and OpenAI team they added like reinforcement learning and human feedback, with transformers, and then they trained models and GPT models, and then it became ChatGPT. So with generative AI within computer vision now, a different type of applications started to get more focus. For example, visual question answering. So this is something it has been around for a long time, but the ability of the model to answer questions from a visual input was very limited at that time. Now with Gen AI, the way the outputs are produced are much more reliable. And it can be used for image captioning. Given an image, it can describe or give a description of what is in the image. And it can also be used in industrial automation and quality control, and also like autonomous vehicles. We are looking at self-driving cars. So whenever a new like feature is needed, or new type of activity, or new scenario needed to be handled, so traditionally we would train another model for that. Now just with fine tuning, VLMs with some sample input and output, we are able to get quickly implement that feature or handle that new scenario. And also like creative field is also like getting a lot of assistance from these AI models. just from a prompt we can generate images or designs, or even for creating presentations or slides. So these AI models are helping. So as the field evolves, as computer vision and Gen AI continue to evolve together, there are several key trends and challenges. So one is the multimodal integration, combining vision, language, and other modalities like audio or sensor information. So we can seamlessly like combine all of this into one multimodal model, and then we can look for real-time processing. But the concerns are rising in terms of explainability. So once a model makes a particular decision or gives a specific answer, why that happens or why that model decided to give that output, so that being able to explain or look into the model and why it did something is becoming a bit more challenging, as these systems are becoming complex. So this we can also like take the analogy from a human brain or from a human person, right? When someone makes a decision or someone feels a certain way, sometimes it's hard to explain why our human brain thinks that way or why someone feels that way. So it can go back to all the things, all the experiences we might have had, and all the things we have seen. So it's hard to pinpoint like why that is the case. So that analogy is also like coming into LLMs and VLMs as they become more and more intelligent, and the models are more and more complex. And also these ethical considerations, right? If these models can be like potentially misused or biased with in terms of training data, or if they are used for taking decisions without human supervision, then that can become a concern. And also like privacy concerns, whatever the interactions we are having with these models can be used for training them, and then if some humans can look at the data that we are providing them in certain scenarios. So we need to be like aware of these ethical considerations. So with computer vision and Gen AI, I mean, it is definitely like transforming the way we are using computer vision, and the capabilities are expanding. And it is also like with these, it is becoming easier to build applications or models for for a variety of industries, and it can have a positive impact. And as a like a future outlook, we also need to look at how these sophisticated systems can be like made better and address these concerns. So let's also like take a like brief look into this LLM architectures. So the basic foundation for these architectures are, as I said, the transformer model. So the architecture was introduced in this paper, attention is all you need, in 2017, and it basically like revolutionized this, natural language processing, NLPs, and it became the foundation for all of these, modern LLMs. So the within transformer, the specific mechanism called self attention, it allows the model to look at different parts of the input and understands the meaning within that context. Basically, like giving attention to different parts of the input to get a better context. And then transformer like allowed for parallelization, like unlike previous frameworks like RNNs that were being used for text processing. Now it enabled much faster training to process these tokens simultaneously. And then there is technique called positional encoding. So it preserves this sequence order information within the input. And then we also have this feed forward networks. So this specific architecture actually helped or enabled the scaling of these language models to unprecedented sizes. Now we are looking at models with billion parameters, which can process context window of like 1 million tokens. So that's the like current state and how powerful these current LLMs are. So in the transformer or LLM architectures, the main is the encoder decoder architecture. So the encoder processes the input sequence and creates a contextual representation that captures the meaning of it. And then with the decoder it generates the output sequence tokens using the encoder's representation and then previously generated tokens. So now this is finding applications in translation, text summarization, question and answering, and other related tasks. So earlier models like BERT, T5. So these are like popular encoder decoder models at these generative tasks. And as I said, the self-attention mechanism is the core innovation that enabled transformers to process language very effectively. So the core idea is each word in a sequence attends to all other words, calculating the relevant scores to determine the contextual relationship within that input sequence. So the real advantage for this is like it enables direct connection between any two positions in solving the long range dependency problem. Meaning, so if you look at ChatGPT, like we can give an input of like very long text, so it still maintains that relevance between different words in that long input, and also like as we have the conversation, it remembers the relevance between the initial word and the last word we had. So within this like encoder decoder architectures, there are models that can be like categorized into different models that are like encoder only or decoder only, or like it can have both encoder and decoder. So the initial models were called like BERT. Now the recent architectures are like GPT.
When? Who's your guide?
So GPTs are like generative pre-trained transformers. So there are like different pros and cons for between this earlier architecture and the current GPT architecture. So another thing we keep hearing about is like the scaling laws. So the scaling law is like it describes how model performance improves, with increases in model size and training data and compute resources. So even though like we increase, the model size or training data and compute resources, at some point, we start to get, diminishing, improvements from these, uh, you know, increases in size or resources. So there are different like methods and research are going on how to like scale the models and continue to improve the performance. It should not like hit a wall, after a period. So in terms of training methodologies, modern LLMs typically follow like a multi-stage training process. So it starts off with a pre-training, learning general, language patterns from, a large, collection of massive text, and then adapting that, with fine tuning for a specific task or domains, using labeled data or, with techniques like RLHF, like the reinforcement learning with human feedback that aligns the model outputs with human preferences, through, comparison based learning. And then it also like, continuously learns, kind of ongoing updates to incorporate, new knowledge and adapt to changing requirements. So each stage actually builds upon the previous one, and with the most advanced models, are incorporating all of these techniques and trying to get the maximum possible, performance. So now, the future directions in LLM architectures are like moving towards, mixture of experts models, like specialized subnetworks activated based on input, and then, increasing parameter count without, compute increases. So and the models are becoming multi-modal, one unified architecture that seamlessly, processes text, image, audio, and video, and then hardware optimized architectures like models designed specifically for efficient execution on, specialized AI hardwares. And this another area is like RAG, like the retrieval augmented generations. So architectures that combine like given knowledge, like given reference, inputs, and then it kind of enables dynamic access to that knowledge bases. So we looked at, the transformer foundation, that became the basis for, all of these modern LLMs, and there is also like architecture differences, encoder based and decoder based models, and then, we looked at scaling laws, and then the future direction is like moving towards, mixture of expert models and multimodal models. So in terms of like learning resources generally for computer vision or machine learning, so there is this course called machine learning in Coursera. I think now it is also available in deeplearning.ai.
ಮ್ಯಾಮ್ ಹೋಗ್ಬಿಡ್ತಿದ್ದವ್ರು ಇರಿ ಮ್ಯಾಮ್ ಅಂತ ಹೇಳಿ ಇರ್ಸಿ ನಾವು ಓದ್ತಾರೆ
So this machine learning course can be like a starting point for anyone interested in, in this field.
Participants, if you have any queries, you please ask. Participants, if you have any doubts, please ask.
No queries, ma'am.
Okay, ma'am. Arun sir, can you hear me? Arun sir?
Can you hear me now?
Sir, can you hear me, sir?
Yeah, yes, ma'am. Can you hear me?
Sir, actually, I have one query.
Yeah.
It is like, so can you please tell us some kind of sources where they could fetch the images for different kinds of applications? Like apart from Kaggle and these kind of repository, if there is any kind of authenticated repositories available where we could fetch the resources for our work for modeling.
Apart from which one, ma'am?
Apart from Kaggle,
Okay.
yeah.
So for images, the main data set is the ImageNet data set. ImageNet is the larger one. And then for object detection, there is a data set called COCO data set.
Yes, sir.
So these are the like larger data sets, like that are open source. And apart from that, there is one more thing from Google that is, I think, ObjectNet, I think. Yeah, or open objects. So that is also like similar to COCO dataset. Apart from that, there is also like a tool called dataset search tool from Google. So it is like a search engine specifically designed for searching datasets. So that
Okay,
also
sir.
can be used for.
Sir, and one more thing, with regards to like we have this for object detection, we use this YOLO models we use, and we do have remaining two-stage models also we have, right? Pre-trained models and two-stage models. So which would you prefer for which kind of applications, sir? Which will be better?
Two-stage models, like what do you mean, ma'am? It's like you mean pre-trained models. Okay.
Pre-trained models, I'm telling about YOLO, these kind of models. And two-stage detectors we have, right? Apart from this one, ResNet and all this thing we have, right? That one.
Like faster RCNN.
Yeah, exactly.
Before YOLO.
Yeah. Because nowadays even we do get better accuracy in that one. What I would feel is like one is giving accuracy better and in some another case. So because now we have various advancements in YOLO as well. We do have mobile version of YOLO, E and all this thing has been launching. Yeah. So what would you suggest, sir, for doing in kind of object detection? Which kind of algorithms would be better for working on that?
So for object detection, recent YOLO models are are better. but again, it depends on like where we want to deploy. Sometimes if you want to deploy to mobile, TensorFlow Lite support is needed. So typically, like models in the TensorFlow repository, like efficient det, mobile det, those models, since they are from TensorFlow team, they'll be more supportive for TensorFlow Lite. But other than that, nowadays, like VLMs, even smaller VLMs, models like small SMOL. So one small VLM, can be used to detect a variety of objects. They are even like able to detect and give bounding boxes. So now maybe like people are looking at how VLMs can be used for object detection. So YOLO and other object detection models are on one side, and now the VLMs are coming and trying to do multiple tasks from one single model.
Yes, sir. Fine.
Yeah.
Participants, do you have any other doubts? Anybody else? So if there is no doubt, we shall wind up. Arun sir, thank you so much for giving your time and participating and giving a session in this one. So really, it was a useful session and mostly given most insights into computer vision and LLM architectures. It was good. Thank you so much for your time and presence over here, sir. Thank you so much.
Yeah. Thank you for the opportunity, ma'am.
Yeah, thank you, sir.
Thank you.
Thank you. Participants, kindly fill in the feedback form posted over in the chat, as well as I'm posting it in our WhatsApp group as well. Our next session will start in another 5 minutes. Shrikant sir, can you hear me?
Yes, ma'am.
Sir, am I audible? Sir?
Yes, ma'am. Yeah, Am I audible?
Your voice is very low, sir, actually.
Okay, just give me a minute. Now, is that fine, ma'am?
Yeah, it's okay.
Okay, just give me a second.
Yeah, we should start the session in another 3 minutes, sir. Still more, it is little voice.
Just a minute. I will. Hello. Hello, ma'am. Am I audible now?
Sir?
Yeah. I will rejoin, ma'am. Right. Just give me.
Yes, sir.
Hello. Okay. Now I'm audible, ma'am. Right.
Yeah, sir. Yeah.
Okay. Okay. Great.
1 minute, sir. Make you as a presenter so that you can share your screen.
Sure. Sure.
Sir? Shrikant, sir, can you hear me?
Yes, ma'am.
Sir, I made you as a presenter. Please share your screen, sir.
Sure. Okay. My screen is visible, right, ma'am?
Yes, sir, it is loading.
Sorry.
It is blurred, sir. Actually, it is loading.
Okay. Now?
Yes, sir. It is okay now.
Okay. Okay. I'm on the, you can see my first slide, right?
Yes, sir. 1 minute, sir.
With the topic.
Yeah, I request Anita ma'am to give the introduction.
Sure.
Good afternoon, everyone. Myself, Anita K.R., Assistant Professor from the Department of Computer Science and Engineering. I take an immense pleasure in welcoming our speaker of today's session, Dr. Shrikant Jere, sir. He is specialized in generative AI and natural language processing. On behalf of Ramaya University of Applied Sciences, it's my pleasure to welcome, sir. So before handing over the session to our speaker, now I'd like to give a brief summary on Dr. Shrikant Jaresar. Sir has accumulated nearly 5 years of comprehensive experience in the field of data science with a specialized focus on natural language processing and generative AI within the technology industry. Currently, Sir is working as a decision science practitioner, associate manager at Accenture AI, leading innovative projects that harness the power of NLP and machine learning to deliver impactful solutions. Sir has developed a robust skill set through various roles encompassing project management, technical consulting, and data science, with a strong emphasis on machine learning algorithms and data analytics methodologies. Sir has achieved a significant advancements in the current role by successfully developing and deploying multiple proof of concept projects that enhanced NLP capabilities, resulting in improved operational efficiency and client satisfaction, and so on. There are many more which Sir has done. So since we are shortage of time, now I'd like to welcome Sir Dr. Shrikant Jaresar on behalf of Ramaya University of Applied Sciences. It's a great pleasure to have you here with us, sir, virtually. And I once again thank you for taking your time and sharing your knowledge with us. Now I hand over the session to you, sir. Welcome you again.
Thank you, ma'am.
Thank you.
Okay. Hi, good evening. Here our topic is security perspectives and research opportunities in the frontier scale revolution. So
Sir,
here are
actually,
the
sir, sorry to
hello.
interrupt you.
Okay.
Your voice is little bit, it is slow, sir.
Okay. Hmm. Just hello. Now
Yes, sir.
I
Yeah, it's
okay.
good, good. Yes, sir.
Okay,
Thank
fine.
you, sir.
Okay. Here is an outline of the content we will be covering in this particular session. First, I will go through the introduction. We will start here with an overview. What exactly is frontier scale AI? And then we will talk about the journey from generative AI to agentic AI. Why agentic AI is basically a next step. We will go to see here. And then research opportunities in generative AI for agents. Here I will go through two research papers related to these particular topics. First one is reducing hallucinations and ensuring factual grounding. And the second one is improving reasoning and long-term memory for agents. After that, we will see future outlook, like how like what are the key research needs in cross-disciplinary areas, like if we use like a cyber security, quantum computing, ethics, and governance with agentic AI, what are the research needs? We will go to see that. Then the next one is high impact domains for agentic AI. So how we can basically use this particular agentic AI in domains like healthcare, finance, education, and science. If time permits, I will just provide you the demo on a healthcare multi-agent chatbot. Okay. So coming to the introduction, first we will see what is frontier scale AI. So here, frontier AI means it's the most powerful generative AI systems which we have today. Like we have many large language models available today, like GPT models. It could be GPT 3.5, GPT-4, GPT-4o, GPT-4o mini, or the Gemini models. We have many like a large language models from Gemini, like Gemini 1.5, Flash, Gemini Pro, and we have Claude models like we have Haiku, Sonnet. These are all the Claude models, and we have Mistral. There are a lot of LLM models available in the market. Okay, so these are basically very powerful, I can say, generative AI systems. because why these particular LLMs are powerful in the sense they have they are trained on a huge amounts of data. For example, if I talk about GPT 3.5, it is trained on 500 plus GBs of data. Okay, and it is these particular models are having billions, millions and billions of parameters. Okay, that help them learn. Why we why we need like a huge amounts of data to train LLM is because it has to understand the vocabulary, it has to understand the language, it has to understand the relationship between the entities. Okay, there are so many parameters we are training to these particular large language models so that it can learn with large scale unstructured data. Okay, we are not supervising anything to uh, basically to learn these particular models. Okay, so here frontier scale, it does not actually what I'm saying, it does not mean big models like I have built a model like large language model with billions of parameters or trillions of parameters. It is not like how big your model is, how it is contributing in NLP capabilities. Like for example, training 1 terabytes of data with trillions of parameters. Okay, even though if you train with large number of parameters, it is not contributing to its your capability, then it's of no use, right? So suppose in terms of capability in the sense NLP capabilities include text summarization, text classification, question and answering. These are the capabilities. Okay, it has to, whatever the models you build, it has to contribute to these particular capabilities, NLP capabilities basically. Okay, this is what we meant by saying frontier scale. Okay, it is not just I mean big models. It's about the big jump in what these AIs can actually do, like reasoning through problems, writing a code, understanding the text and images together. Okay, how this is basically a multimodal thing, right? We are giving text as well as the image. Okay, and we are asking on top of that we are writing the prompt. Okay, and also whatever the models we are building, basically we want to have um, like a models like it can take its autonomous decisions. And here before going to proceed with the next whatever the topics are there, I want to define some of the some of the key terminologies. Okay, so that you can comfortably understand the next set of things what we will be discussing. Okay, first one is generative AI. All of you know what is generative AI. You have at least you have used it, like you almost all of you have used chat GPT. Okay, what is the use of a chat GPT tool? You give basically a question, and chat GPT will provide you the answer. Okay, you have used it for question and answering capability, right? And also you have used it to generate the codes, you have used it to generate the images, codes. Okay, uh, so on and so forth. Okay, so here basically generative AI is a powerful tool for creating new content like text, images, or code based on prompt. What is prompt? Whatever the user is giving input to the chat GPT, that is called the prompt. Okay, the input is a prompt basically. Okay, you give prompt to the generative AI model, and it is going to generate you the content. Okay, such kinds of models are called generative AI. Okay, behind the scene we have the large language model uh, to generate the responses basically. Okay, next, coming to agentic AI. Agentic AI builds on these particular generative AI models. Okay, but adds a layer of proactive autonomous behavior. Okay, for example, I will tell you why one of the use case of agentic AI. Okay, suppose you are using chat GPT and you are asking a question. Okay, you are asking a question, uh, uh, what is the weather today? Okay, what is the weather today? Here chat GPT cannot provide you the and provide you this particular answer. Okay, because it is trained on the LLM is trained on the past data. LLM is trained on a data till 2023. Okay, so it is not chat GPT is not basically trained on day-to-day information. Okay, it will not be able to provide you the information of today's weather. Okay, so in agentic AI, what we can in a agentic AI architecture, what we can do is we use a LLM, but we will connect some tools to that particular um, LLM. Okay, so whenever I ask a question like what is the weather today? It will understand that particular question and it will search in the in its database in its basically trained knowledge. Okay, if that particular knowledge is not there, what it will do is it will call the it will pass that particular question to the tool. Okay, and that tool will generate this basically this tool is having the weather API. Okay, weather API is we have we are using in that particular tool, and that particular weather API will get the answer, and then whatever the LLM is there, it will receive that and it will properly rephrase that particular it will use that and frame frame a response. Sorry.
ಯಾಕೆ ಎಲ್ಲಾರ್ದು ಹಿಂಗೆ ಬರ್ತಾ ಇದೆಯಾ ಬ್ಲರ್ ಬ್ಲರ್ ಆಗಿ?
Hello.
Hello, sir.
Hi, ಹೇಳಿ ma'am.
Sir, actually, screen is blurred and it is not moving. It is still in important key terms itself.
Yeah, yes, ma'am. I'm on important key concepts only.
Okay, okay.
Yeah, is that blur
Fine,
or like?
Yeah, it is blurred and it is turning back and blurred and turning back. It is coming.
Okay, now, ma'am.
It is okay, sir, now.
Okay, yeah.
Ah.
I'm on this important key concepts only, ma'am.
Okay, okay, fine.
Okay, so here we are attaching tool to that particular LLM. Okay, yeah, so that it can have the weather information. uh, it can get the weather information from that particular tool. This is what agentic AI we are adding. Basically to agentic AI we are adding the tools, we are adding the memory to retain the context. So on top of this particular generative AI, we are having this particular solution in agentic AI. Okay, next the third concept is AI hallucination. Okay, you can see this particular example. Einstein won the Nobel Prize in 1925. Suppose this is the information we have got from one LLM. Okay, this is the response of an LLM. Okay, now by seeing this particular statement, you will feel that like this particular information, whatever it is providing, it is correct. Okay, because how confident our LLM is so confident in providing this particular response. It is not saying no, it is not saying I don't have this particular information. Rather, it is confidently giving Einstein won the Nobel Prize in 1925. But factually, if you see, that is incorrect. Okay, this is called AI hallucination. Here, the AI model generates content that is fluent and confident, but factually incorrect, irrelevant, or entirely fabricated. Okay, this is called AI hallucination, giving a wrong information confidently. This is what called the hallucination. Hallucination equals to confident but wrong output. Okay, next we will see why we actually require agentic AI. Okay, basically why agents are the next step using this particular example. Okay, here this is the here this is the goal. we want to plan a weekend trip to Ooty. Okay, we are using AI to plan that particular trip.
Shrikant, sir,
Yes, ma'am.
sorry to interrupt you. It is blurred again, sir.
Okay,
Uh,
I'm not sure why this is blur. I have Mac. Can you share your screen otherwise, ma'am? If you
yes,
have
sir. You
my
share
PPT.
the same PPT, sir.
Same PPT, ma'am. Yes.
Okay, sir. 1 minute, I will share that. So, shall I share the PPT or PDF, sir? Which one is preferable?
Anything is fine, ma'am. Not PPT.
PDF.
You please share PDF, ma'am.
Sure, sir.
Because PPT
1
is
minute.
like,
Yeah.
it is converted one. I'm not sure.
Yes. Can you able to see, sir?
It's loading.
Okay. Participants, can you able to see my
Hi.
screen? Is it clearly visible?
Yeah. Yes. Yeah.
Yes, sir.
I
Please,
can
sir.
see.
Yeah.
Okay. Okay, here we will see how agentic AI is powerful using this particular example. Okay, here the goal is to plan a weekend trip to Ooty, and we are using here agentic, basically AI. Okay, there are two approaches here. One is generative AI approach, and the second one is agentic AI approach. Okay, here we will in generative AI approach, we will ask a prompt. We will ask a generative AI LLM using a prompt. Write a 3-day travel plan for a trip to Ooty. Okay, what it will do? The model will take this particular input. Okay, and here the model's sole action is to generate a text-based project plan based on its training data about Ooty. Okay, and output will be a list of places suggested activities. It will provide some it will suggest some activities. Okay, and here one thing you can see, the output is static. Okay, that is what its limitation is. If you see the limitation, suppose if you need to book hotels, if you want to check the flight prices, or finding a specific restaurant. Okay, it will not be possible with your generative AI, because it is not connected with some tools. Okay, suppose you want to book hotel. Okay, then it has to be connected with certain API. Okay, and suppose you want to check flights. Okay, it has to be where you will get the information. You should have some API, right, to get the information about all this. Okay, or there should be some web scraping APIs you need to write to extract the data from extract the things from the website. Okay, and day-to-day flight charges. Okay, flight prices, it is going up, down. Okay, you need to get that information. That will not be there in in your large language models like GPT 4 or GPT 5, whatever. Okay, so that is what the limitation is. Okay, here here generative AI, in the generative AI approach, you have a large language model. It is trained on the past data, and you cannot plan your trip completely. Okay, like booking the hotel and all. Okay, now coming to agentic AI approach, here agentic AI is basically having a objective or a goal. Okay, here the objective of this particular system is to plan and book a fun and affordable 3-day trip to Ooty for 2 people next month. This is what your prompt is. Okay, plan and book a fun and affordable 3-day trip to Ooty for 2 people next month. Okay, this is what you want to do with that particular agentic AI system. Okay, and what agentic AI system will do here, it will plan, it will execute, and it will monitor. These three things it will do. Okay, coming to planning stage. Okay, the whatever the agent we have, it will first break down the complex goal into a series of smaller manageable tasks. For example, this entire thing, planning and booking a trip, it is divided into 4 tasks. First task is check for the best dates and prices for flights or the trains. Second, search for affordable hotels with good reviews for those dates. Third task is to create a detailed day by day travel plan with activities. Fourth one is book the flights and hotels based on your preferences. Here there are 4 tasks. Basically we can create 4 different agents. Okay, 4 different agents, so that we can have 4 tools. We can define 4 tools for 4 agents. Each one of the each tool is having the basically using the APIs to get the required information. Okay, this is in the planning phase. Basically it has divided into 4 tasks. Now in execution step, we whatever the um, agents we have created, it autonomously execute the plan. First one, it uses an API to search travel booking sites for flights and prices. Second agent uses another API to find hotel listings within a specific price range. And the third agent might use a web scraping tool to check local events or the restaurant reviews. The fourth agent sends you the final plan with booking links for your approval. Okay. Now, in the monitoring phase, the agent, what the agent will do, agent will continuously monitor the situation. If a flight price drops or a better hotel deal become available before the booking is confirmed, it will notify you these particular information, so that like you can go with these particular new plans. Okay, this is what your agentic AI is doing. It will plan, it will execute, it will monitor, but this is missing in generative AI approach. Okay, generative AI approach basically produce the static output. Okay, you can go to next slide, ma'am. Okay, yeah. Now we will go through agentic AI frameworks. Okay, there are suppose you want to build your own application uh, um, using agentic AI approach. Okay, so here there are multiple frameworks available in the market. Okay, I have listed 3 of them: Langgraph, Autogen, Crew.ai. These are the frameworks. Okay, you can find it in Python. Okay, these are all the Python libraries. Okay, Langgraph, Autogen, Crew.ai are the Python frameworks. Okay, you can use these to build your agents as well as the agentic workflow. Okay, now when you want to build your own project, you need to choose your framework first. Okay, that is the first task. Okay, how you will choose the particular framework? It depends on these particular parameters, like primary focus. What is your primary focus of your application which you are building? Multi-agent workflows, flexibility to create custom agents, community support, context persistence, visual workflows, scalable production. Okay, these are all the parameters you need to see before choosing the Langgraph. Before choosing these particular frameworks, um, to build your application. Okay, coming to Langgraph. Okay, so here the primary focus is to build the complex workflows. Okay, suppose if your application primary focus is to build complex workflows, then you can go through Langgraph. Okay, you can easily build with Langgraph. Next, whether you have to see whether your framework supports multi-agent workflows. Multi-agent means you can have multiple agents. Okay, like how yeah, in my previous slide which I have shown you, we were using 4 agents for 4 different tasks. Okay, we have multiple agents there. Okay, more than one agents we can have it in a workflow. Okay, so here Langgraph supports multi-agent workflows. We can develop n number of agents. Okay, and put it in the workflow. Next, whether whether LangGraph is flexible to create custom agents. Yes, custom agent means we can create our own tools and we can attach it to that particular agent. Those things we can do it. Uh, when I say it is not flexible, suppose a framework whoever have built this particular framework, they have build some of the agents, and we don't it's a black box. When we don't have any control to customize those particular agents, that I will call it as a less flexible one. Okay, LangGraph is highly flexible because we can write our own agents, we can create our own tools. Okay, we can create our own workflows. Okay, we can basically we can control our entire agentic AI workflow. Okay, that's why I call it as a highly flexible. Next, community support. Yes, LangGraph is having community support. Can you go to that particular slide, man? Okay. Community support is strong. Sorry, the slides are moving, ma'am. Previous slide only. Hello. 8th slide. Yes, ma'am. Yeah. Okay, visual workflows. We can have a visual workflows, like we can create a graph of those particular workflows, how orchestrator agent is redirect to the respective agents. Okay, we can see our we can have our own a workflow, and we can see it using the graph. Okay, and LangGraph is highly scalable, means you can use n number of agents. There is there is no issue with the scalability with respect to LangGraph. Coming to Autogen, if our application's primary focus is on agent design with predefined patterns, then we can go with that. But it is also highly flexible, but not for the complex workflows. And Crew.ai, we use it when we require rapid prototyping. It is less flexible, means they have their own set of uh, 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 agents. Okay, those are black box. We don't have it is very difficult to customize those particular agents. And coming to Autogen and Crew.ai, community support is moderate, context persistence is moderate, and visual workflow is limited, but these two are also highly scalable. You can go to next slide, ma'am. Okay, now we will go through research opportunities in generative AI for agents. So here we will see two research papers. Okay, I will go through that, and I will tell you what are the limitations where you can do some research in those particular research gaps. Okay, yeah. Slide 10. Okay, here the first research gap is to reduce the hallucinations and ensure the factual grounding. As I said, when I talked about AI hallucination, some of the LLMs confidently provide the answers, okay, but those are factually incorrect. Okay, how you will mitigate this particular hallucinations? Okay, that is what this particular research topic is all about. Okay, here I will go through this particular paper, mitigating LLM hallucinations using a multi-agent framework. This is published in Information Journal, MDPI, in 2025. Basically, here the problem statement is LLM outputs are inconsistent in production. Hallucinations block dependable deployment at scale. Okay, so when we deploy these particular LLM models, okay, LLM models, they tend to hallucinate it. Okay, means they confidently provide the answer, but factually incorrect. Okay, this is what the issue is. Okay, now in this paper, what they have developed one framework, okay, to mitigate this particular LLM hallucination issue. Okay, this is the proposed approach. You can see the diagram on the right. Okay, this they call it as a multi-agent framework. Okay, they are having two agents basically here. One is consultant agent and the other one is evaluator agent. Okay, there are two agents here, consultant agent and evaluator agent. Okay, whatever the input we give, I will give one example for the input. Who is the Prime Minister of India? Who is the Prime Minister of India? This is the question. This will go to consultant agent. Okay, what this consultant agent does, it will generate the answer. It will generate the answer. Okay, the current Prime Minister of India is Narendra Modi. Okay, this suppose this is the answer. Okay, now we have one more agent called evaluator agent. We have one more agent called evaluator agent. This will receive the response provided by the consultant agent. Okay, the current Prime Minister of India is Narendra Modi. Okay, now what it will do, it will this particular evaluator agent understand this particular response, and it will check uh, this particular its knowledge base basically. Okay, for example, the knowledge base could be your Wikipedia knowledge base. Okay, what it will do, in the response you have the entity like Narendra Modi. Okay, it will search for that particular Wikipedia page Narendra Modi. Okay, and it will retrieve all the context. Okay, and it will send back to this particular evaluator agent will receive that particular entire context. Okay, and it will write a prompt. Okay, already the prompt is written in evaluator agent. What this prompt is like, I am providing you the um, a prompt response provided by consultant agent. Okay, so and so is the response, like the current Prime Minister of India is Narendra Modi, and you can see the context below, which is a Wikipedia information, Wikipedia text. You provide it. Okay, whatever you have got it from the knowledge base, and you say prompt like you just check whether the response is correct or not from the given context. Okay, it will say whether it is correct or not. Okay, if it is correct, it will provide this particular response will go to consultant agent. If it is not correct, it says the response contains two information. One is the first information is it has to say whatever you have got the response that is incorrect, and this is the second thing is this is the proper information, whatever the proper information is. Okay, this is what this particular multi-agent framework does. Okay, next slide. Okay, here the authors have used two models basically to um, like for this particular uh, like whatever the AI system, agentic AI system they have built. Okay, first one is MetaLlama 3.8 B, and the second one is Mistral 7B. Okay, with MetaLlama 3.8 B, okay, they have improved up to 85.5%. Okay, uh, this is what the metric improvement is. Okay, and using Mistral 7B, they have improved up to 67.7%. Okay, and they have achieved with the 2 iteration consultant evaluator loop. Okay, till you get the proper answer, it has to what it has to do, it has to iterate it. Okay, that is more important. Suppose even though if I get Narendra Modi page from the knowledge base, which is basically um, from the Wikipedia. Okay, here it has not got that particular information. Then what it will do, it will go to another, it will send back that particular response. Okay, again it will say the first agent will say just check in Prime Minister page. Okay, Prime Minister Wikipedia page, Indian Prime Minister Wikipedia. Okay, if that particular in that particular page, uh, suppose if it is having that particular answer or the response, then it will again give back to that particular agent. Okay, generator agent. Okay, this is a loop. Okay, there they have whatever the measures you are seeing for Metalama and Mistral 7B. For this, they have used 2 iteration consultant evaluator loop. Okay, next, coming to the limitations, the evaluator agent is domain specific. Okay, rules need to be carefully aligned with the task. Okay, this is what the limitation. Okay, authors have done this for a particular domain. Okay, not for a generic. They have not developed it as a generic solution. Okay, this is what the first limitation. Second one is the framework has been tested only on English open domain call data. Okay, so here you can do this is an open area where you can build this particular system. Okay, basically multi-agent framework for regional languages like Kannada, Hindi, Marathi. Okay, you can you can collect the data, and you can fine tune your model for these regional languages, and you can just try and test, and you can here when you develop these particular frameworks for your regional languages, there could be other challenges. Okay, like here it is not like a straightforward like English, like because here in English we can get large amount of data. Like if we want 1 terabyte data also, we can have it, but with respect to regional languages, there will be a limited data. Okay, if I want to search for the data for Kannada language, it is very limited. I cannot have such a huge amount of data. Okay, and each second problem is like each regional language have its own grammar. Okay, like I feel like um, training the information about the grammar. Okay, it is very difficult. We need to have a large amount of data so that it can learn by itself. That is one thing. Okay, from which we can mitigate this particular issue. The next limitation is domains like medical or legal are not included. You can work on these particular domains. Okay, last one is the approach provides post generation verification only with no retrieval based grounding to external sources. What I mean to say here is like whatever you are mitigating the LLM hallucination, this is after generating the output. Okay, we are not making the LLM not to hallucinate for a given prompt. Okay, instead what we are doing is we are taking the response from the LLM, and then we are checking whether it is correct or not. Okay, so here the system checks the response after it has already been generated. Mistakes or hallucinations are only detected once the output is complete, not while it is being generated. We don't have any control over LLM response generation. Okay, what this particular paper says, whatever it basically works on top of the generated contents. Okay, that is what the limitation here. Any doubts here in this paper? Can I have some questions?
கரண்ட் போடலையே எனக்கு செஞ்சு விட்டால
Hello, any questions here?
Participants, if you have any queries, you please ask. Otherwise, kindly mute your mic.
Okay.
Is there any queries up to this? Sir, please proceed, sir.
Sure. Yeah. Second paper is related to improving reasoning and long-term memory for agents. Okay. Here the paper title is Memo Building production ready AI agents with scalable long-term memory. Okay, this paper you can get it in archive.org. Okay, and this particular paper is published in 2025. Okay, now what exactly this particular like research gap is like? Here you can see the picture on the right side. Okay, here like user has asked the question, I'm vegetarian and avoid dairy, any dinner ideas? Okay, and LLM is able to provide the response, try these dairy free veggie recipes. Okay, this he has asked a previous day. Okay, he has got the response. Next day for the he has started the new session. Okay, and he is asking, what about dinner tonight? Okay, it is responding back, how about chicken Alfredo? Okay, on the previous day he has said like he is vegetarian. Even though he says vegetarian, it is giving some like a non-vegetarian. It is suggesting some non-vegetarian food, right? So it is forgetting the uh, like users information. Okay, it forgets the it has forget the user is vegetarian and dairy free. Okay, so this is what the issue we have. Okay, in the current LLM. Okay, or what current LLM does is like it can have only limited amount of context. Okay, maybe it can retain the previous day information or last 50 conversations, not more than that. Okay, now you can see the second conversation here. I'm vegetarian and avoid dairy, any dinner ideas? And LLM has provided the response. Next day, he asked the new question, what about dinner tonight? Now, it is providing the answer like, how about a creamy cashew pasta sauce? Because it has retained the context basically. Okay, it like our LLM or agentic AI systems has to retain the context basically, has to retain the context. Um, and even though if it retain the context like it is very difficult to retain long term context. So how to handle how to remember the long term context, that is a research gap here basically. Okay, here the problem addressed is like LLMs face limitations with fixed context windows, poor at sustaining consistency over long multi-session dialogues. Suppose the first conversation is happened before 100 conversations. Okay, now your agentic AI is capable of um, retaining only 25 conversations or 50 conversations. Okay, then it will forget all previous context. Okay, it is not having the um, like it is not having basically a context window to store all the um, context basically. And even though we can retain it using RAG application, we can have a RAG architecture, right? um, uh, like uh, um, uh, we can store the whatever the conversations are there, like 100,000 we can store it. But when you in the production, when you deploy these particular models with RAG, these are too slow. Okay, either it's a token inefficient or it's too slow for real-time development. That is what the issue with the RAG. Okay, it is not like we can build it using RAG, but RAG is also having some limitation in providing the response in a efficiently in a required amount of time. Okay, there is a need for scalable persistent memory mechanisms that enable LLM agents to truly remember over time. This is what the problem is. Next slide, ma'am. Okay, so here they are using some two variant models. Like first one is memo based model and the other one is memo G model. Memo G in the sense memo graph. They are using some like a graph architecture to store the context basically. Okay, so here coming to the first one memo, what they are doing is they are having basically they are retaining the context. Okay, suppose after having some 50 conversations, what they do, they will summarize that particular entire conversation, 50 conversations. Suppose these particular 50 conversations having like uh, 2000 or 3000 tokens, they summarize it to like a particular context window size, like for example 100 tokens. Okay, summarizing 2000 tokens into 200 tokens. Like this we can go on summarizing the context. Okay, over the period of time, like after 50 conversations, or it will be better after doing summarization after having some 2000 tokens or 3000 tokens, whatever. Okay, and it depends whatever the number is there. You can just try it out, you can just experiment it for your application. Okay, how well it suits. Okay, and also it depends on how well which model you are using. Okay, the model, some models are having the larger context windows, some models are having smaller context windows. Okay, it depends on which model you are using. Okay, this is what this memo base says. And in memo G, next slide ma'am. In memoji, what will happen is whatever the we are using graph based memory. Okay, we are each node is having basically each node stores certain information. Okay, for example, one node stores the information related to your food, and other node maybe storing the information with your other interests and all. Okay, so we store each particular entity in a separate node, and that you summarize that particular node basically. Okay, this is what this particular memoji architecture is. Okay, so here they are using these two basically two different architectures they are using. Any question here?
Participants, do you have any queries till now? So please proceed, sir.
Okay. Can you go to the next slide, ma'am? Next slide. Okay. Now we will see the future outlook. Here, as we say, AI agents are the next big steps in technology. Okay. Because we not only want to generate the generate the static content, but also act, plan, and make decisions. Okay, that's why we our journey is from generative AI to agentic AI. Okay, and we require cross-disciplinary innovation to scale safely. Okay. Yeah. So now coming to the cross-disciplinary research needs, here we are having the cross-disciplinary fields like cybersecurity, quantum computing, ethics, governance. Okay, how we can utilize these particular fields in agentic AI. Okay, that is the research need. Okay, how we can utilize cyber security in agentic AI systems, how we can use quantum computing in developing and deploying the agentic AI. Okay, here the focus is we will see the focus and why these particular fields matter. Okay, the first one is cyber security plus agentic AI. Here, we using cyber security, we keep agents safe from attacks and harmful or the basically harmful prompts, like from the prompts ingestion. Okay, this particular agent AI is exposed to the exposed to the world, right? So anybody can write any prompt. Okay, suppose you have developed some chatbot. Okay, like for your or what it will do, you have the organization database. Okay, like how many student, how many PhD students are there, how many what is the strength of last year AI uh, like uh, AI program. Okay, so here you have a lot of information and you want to answer it in the chatbot. Okay, user will ask the question there. Okay, maybe the parents will ask the question. Okay, and it will retrieve it from the your organization data. Okay, yeah, basically that particular question is converted into the SQL statement, and that SQL statement will hit your database. It will get the response and it will show it to the user. Okay, this is what you want to do in your application. Suppose if user has uh, written a prompt like get all the uh, you get all the tables from the first you list out all the tables from your database. Okay, and delete all the records. Okay, this is the prompt. Okay, then what it will do, your prompt will your prompt will list out all the tables from the schema, and it will generate the query to delete all the records in each of the table. Okay, next day you will not have any data in your database. Okay, such kind of prompts user can write. Okay, user can user can write harmful prompts and uh, like to harm your harm your system, right? So we need to guardrail to all such kinds of prompts. Okay, this is done by cyber security and by combining cybersecurity and agent AI. Okay, keep agents safe from attacks and harmful prompts. Okay, basically why it matters? Yeah, basically it protects systems and users from the misuse. Next, quantum plus agent AI. Use quantum for faster problem solving. Okay, but here the issue is you need to defend against quantum threats. Okay, if you want to use quantum, then you need to defend against quantum threats. Here, this particular field enables next gen speed, but also needs security. Next field is ethics plus agentic AI. We need to ensure our agents are fair, explainable, and aligned with human values. Okay, and also like whatever the generated responses are there, it has to explain it well so that user gets the confidence in that particular uh, response. Like for the same example, who is the Prime Minister of India? If it simply says the Prime Minister of India is Narendra Modi, then we may not, okay, we may not accept that. It has to give us the some citations and all. Here from this particular page, I have got this particular information. Okay, and if it provides a link, that's well and good. Okay, and also whatever the Wikipedia page, suppose it is extracting from Wikipedia pages. Okay, it has to provide some citations and all. Okay, uh, page links and all. Okay, this is what the explainable AI means. Basically, this field builds trust and fairness. Next, coming to governance plus agentic AI. It creates rules, policies, and checks to prevent the misuse, and it ensures safe and responsible AI adoption. Responsible AI is very important here. Like your AI system should responsibly provide the responses. For example, if you are asking the question like how to give me some idea to um, like create a bomb, or I want to suicide, can you give me some suggestions? Okay, like this, it should not answer to your questions. Okay, your definitely if you ask these questions in your chat gpt, it will not answer to your questions. Okay, this is what responsibly AI means. Next, high impact domains for agentic AI. So if you want to research on agentic AI, okay, um, uh, uh, like these are the open domains, basically healthcare, finance, education, science, governance, and ethics. There are I have listed out few. There could be many more domains where you can use agentic AI, and we can find some research gaps in those particular domains. Okay, and we can work on that. Okay, so here in healthcare, I am giving some examples here how you can use agents, um, how you can develop like a healthcare agents or a finance agents like that. Okay, coming to a healthcare domain, we can develop virtual health assistants. Okay, and we can develop agents to monitor the patients. Okay, like this we can develop the and also one more agent could be um, uh, like uh, writing a discharge summary. Okay, so here we can automate some of the tasks. Like for example, suppose you want to um, claim to insurance. Okay, you basically people needs a discharge summary, okay, from the hospital. Okay, what these discharge summaries are not actually completely fully written by the doctors will be very busy. Like what they will do, they will give a raw text. Okay, they will not give the complete information. Okay, and these raw text internal insurance guy will take, and he will write the detailed discharge summary. Okay, this particular process we can automate it. Like what we can do is, like whatever the raw text given by the doctor, you just provide this to one agent. What that agent will do, agent will clear it will write a nice discharge summary. Okay, which is having nice discharge summary in the sense it is having the full statements. Usually when doctors provide, it will not be like a full statement or a paragraph, just like a they will just provide the phrases and all. Okay, it will convert it into proper English statements, paragraphs. Okay, and it writes it nicely. Okay, then we can, okay, we can take that particular response in the form of PDF. Your agent can generate PDFs also. Okay, not only the text. Okay, after developing after generating the text, it should put it in a PDF. Okay, and it has to provide suppose it can provide the link to download that particular PDF. Okay, that also works. Okay, this is another example for healthcare agent. Okay, where we can automate some of the tasks. Next, finance. We can create the agents as a smart advisors, fraud detection. Okay, this is the impact is safer money management. Next, in education, we can develop the agents as AI tutors. Okay, and we can develop personalized learning agents. Okay, which improves student outcomes. In science domain, we can develop the agents for drug discovery. Okay, we can develop the agents like research assistants. Okay, the impact is to speed up the innovation. Next, governance and ethics. Here we can develop the agents as policy advisors, rule checking agents. Okay, here the impact is to more responsible AI use. Can you go to next slide, ma'am? Okay, now the most important thing is, like we will we will go through the demo. Okay, I will show you some demo. I will share my screen where I will give the demo of a chatbot. How exactly? Basically, it is having four agents. One is the orchestrator agent. Can you go to the next slide, ma'am? It is having four agents basically. The first one is the orchestrator agent. Okay, you can see on the uh, left side diagram. It is having healthcare orchestrator agent. Whatever the user asks the question, it will first come to orchestrator agent. Okay, now we have three more agents basically. Discharge summary agent, which will take raw text as a raw text and provide the nice discharge summary. And then the second agent is Wikipedia medical search agent. Suppose doctor is having a doctor want to get some information. Okay, some information, he will provide input to that particular agent. Okay, and he will get the response. Okay, and the third agent is symptom checker agent. Suppose patient is having some symptoms. Okay, so the doctor have identified some of the symptoms, and he want to get the detailed information about that particular symptom. So he will give that particular symptom and get the response out of it. Okay, so here basically it is having four agents. One is the orchestrator agent. What this orchestrator agent does, it whatever the orchestrator agent we are having, it manages, okay, all these particular agents. Okay, first whatever the user query comes, it will come to this particular orchestrator agent, and orchestrator agent will understand that particular question, and it will redirect to the particular agent. Okay, it will identify that particular agent also, to which agent might have this particular which agent can give me the answer to this particular question. Okay, so it will redirect to that particular agent, and whatever the response provided by that particular agent, again it will come back to orchestrator agent, and orchestrator agent refine that particular answer and provide it to the user. Okay, this is what the workflow is for this particular healthcare multi-agent chatbot. Okay, now I will share my screen to show you the demo. Okay, first I will go through the demo, then I will run all these particular cells. If time permits, I will go through the code, not in detail, but at least I will show you some of the functions, why we are using that. Okay, it takes some time to run. You can see my screen, right? You can see my notebook.
Yeah, so screen is visible. It's blurred a bit.
I'm not sure why you are.
Participants, can you able to see?
No, ma'am, it is blurred only.
Okay. Sir, if you have this notebook, you please share me.
Oh,
Yes, ma'am.
okay, ma'am.
Can you share the link on WhatsApp?
Yeah, I will share. Sir, you share the link, I will share to them so that they can see.
Okay, I have to share it here, ma'am. Otherwise, I have to download it. Okay. Just provide me your.
Sure.
Yeah.
Prabha Devi, PRABA, DEVI dot Bhupati, BOOPATHY,
THY.
BOOPATHY @gmail.com. You send, sir?
Yes, ma'am.
Yeah. Okay.
You can share the screen.
1 minute. Sir, I didn't receive it. I'm sending you my email in WhatsApp. WhatsApp it.
Okay.
Yeah, sir. Please check in WhatsApp. I shared my email ID.
Okay. I have shared.
Okay. Yeah, just I received.
Okay. Okay. You can share your screen, ma'am.
Yeah,
Once
sharing.
you get that.
Yeah. Is my screen visible?
Just a minute. Yes, ma'am. Yeah.
Yeah, sir.
Okay. You can go to runtime, ma'am.
1 minute.
And execute all the. Sorry.
Should I run all the cells?
Yeah, run all the cells.
It might take more time over here.
Yes.
Yeah, it's fine.
It will take 2. Meanwhile, I will share 3 prompts, ma'am. Just
you share me.
Okay. I will share it in this chat only.
In WhatsApp, you share, sir.
Okay.
The
first prompt. And second prompt is.
Shall I pass on this to audience, sir?
Yes, ma'am, you can share. Yeah. Yeah, I have shared it.
Yeah, I shared.
Okay. You can go to the last cell, ma'am.
1 minute, sir.
Where we have that Gradio, ma'am. You will find the Gradio code below.
This one, sir?
Yes, ma'am. This Gradio code. I think it is running, still running.
Still running, yeah.
Yeah, yes.
Yes, it's done.
Okay, ma'am. Then you can open that link, ma'am. You can see the public URL.
Yeah, I will enter the. Shall I enter the first prompt?
No, ma'am. Here you just run that. You click on the HTTPS, that particular link.
Okay.
It will open it in browser.
Yeah. Yes, sir.
Okay.
Should I enter it?
Yes, ma'am. First prompt you can enter. Okay. Here the first prompt is it is saying like provide the discharge summary. Okay, the discharge summary is you can provide complete prompt, ma'am, whatever I have provided. Yes, ma'am. Yeah, that's a full prompt. Here, doctor has given this particular information, like patient admitted with acute abdominal pain and vomiting. Okay, ultrasound suggests gallstones. Okay, this is not a they have given the doctor has given the raw text. Okay, raw text. It is not like a paragraph or a nice writing. Okay, with the nice writing, what our bot is doing, bot is generating the discharge summary. Okay, where you can find the full statements, and it's and between each statements there is a flow. Okay, you can see the flow of writing, how it is writing. Okay, uh, uh, basically this particular response is generated by the uh, first agent. Okay, what is that first agent? That's the discharge summary agent. Okay, whatever the question you are asking, it will go to orchestrator agent. Orchestrator agent redirect to discharge summary agent, and that response, whatever you are seeing, it is from the discharge summary agent. Okay, now you can ask second question, ma'am.
Yes, sir.
Okay, what are the common symptoms of dengue? Okay, here doctor wants just the information about this particular uh, disease. Okay, now your orchestrator agent will redirect to the agent Wikipedia medical search agent. Okay, now you can see the answer there. Okay, whatever the answer you are saying, dengue fever is a disease caused by the dengue. Okay, this is coming from the Wikipedia medical search agent. Okay,
Third one I'd share, sir.
yes, ma'am. And also we are you can see the chat history. We are retaining the context. Okay, previous conversations also we are able to see here in the chat history. Okay, yeah, coming to this particular question, patient has headache, fever. Okay, that particular question, the orchestrator agent is redirect to symptom checker agent. Okay, and the answer what you are getting there is from the symptom checker agent. Okay, this particular demo I have developed just to showcase the agentic workflow and the capability of LangChain basically. Any questions here?
Audience, please feel free to ask the question.
Like this, you can develop n number of agents. Okay, and can you go to the code map?
Slide, sir.
Yeah, code map.
Code. Yeah, this is code
Yeah,
page only.
yes. So here we are installing LangChain package, LangChain community, the classes, whatever the classes, functions defined in these particular packages, we are using it. Next, okay, you go to please next cell, ma'am. Okay, as you are seeing, you are seeing the front end, um, I have already demoed the front end, right? Where you can able to give your input and all. Okay, this is using a Gradio framework. Okay, we are having the user interface, we are having the backend code, and we are integrating UI and the backend. Okay, for that we have used Gradio framework. Okay, it is like your Flask or a Django, whatever the Python package, Python frameworks you have. It is similar to that. Basically, Gradio is a lightweight Python framework. Okay, yeah, and here we are using OpenAI models. Okay, that's why I have installed the OpenAI package. Okay, the version is 0.28. Next, we are not, we are using a Wikipedia tool. Okay, because this particular agent, Wikipedia medical search agent, it is using this particular package Wikipedia. Okay, we are basically using the Wikipedia API wrapper, where it is having the API to which we are giving the input to get the information about the topic we are sending to that particular Wikipedia API wrapper. Okay, then you just go to the first orchestrator agent straight away, ma'am. Here just we are importing all the packages required.
This one, sir? Down, no?
Below, ma'am. Down, ma'am.
Yeah. Am I right?
Okay,
This
yeah,
one, right? Packages.
yeah, ma'am. These are the packages which we are using. Like here, you can see the third statement from langchain.agents import tool, comma initialize agent. So here to develop the orchestrator agent, we are using the function initialize underscore agent, and to develop some custom agents like Wikipedia agent, discharge summary agent, we need to create the tool. For that, we have the class called tool in langchain.agents. We are using that, and as we are creating the chatbot application using the OpenAI model, we import chat OpenAI class from langchain.chat underscore models. Yeah. Next, we have conversation buffer window memory. Okay. Here, what conversation buffer window memory does is like it will store the, it will retain the context. It will store all the conversations in the memory. Next, we import OpenAI, and then Wikipedia API wrapper. This is for Wikipedia API calling, and we have a LLM chain which we are using for LangChain stuffs, and then we are using prompt template basically to create our prompt and store it as a template. Okay, next, below in the cell 7, okay, you can see OpenAI API key. You need to provide to you in order to call OpenAI APIs, okay, LLMs like GPT-4, whatever the models. Okay, we need OpenAI API key. Okay, we need to generate API key from the website. Okay, and here I'm storing it in a hello.
I have one question, sir. Can
Yes.
we use any search engine, search agent, and can we select any prompt method for any kind of application?
Any kind of
Suppose my application is multimodal biometric recognition using face image.
Okay.
So here, how I can decide which search agent I have to select and which prompt method I have to use?
Agent you need to develop by it's your own, ma'am. We are not we are not using any agent which is already developed, ma'am.
Okay.
We inside the agent, for each of the agent we need to create the tool. In that tool we have the functionalities. We need to write our own code there, ma'am.
Let us see here Wikipedia we have used imported, right?
Yeah. Yeah, Wikipedia, but how we have Wikipedia API like that, you need to have already the APIs like that, then you can use it. If already those particular functionalities are not there, APIs are not there, then you need to create your own, ma'am.
To generate it, right?
Do you have any APIs related to your domain, what you are saying that particular
application
task?
not yet started. Just my question is that's why I'm asking this question.
If you have already developed APIs available, then you can use it, ma'am.
Okay, and what about the prompt methods?
Prompt method in the sense, are you talking about prompt writing skills? It depends on what you want to what you want to perform. So basically how it follows, you need to provide the entire system message, that entire context you have to set, this application which I'm developing is for medical domain. Okay, these below steps you need to follow logically. The first one, you need to identify that particular you need to identify this particular object. The second one, whatever the steps you
Okay,
want
I
to
have
follow
to
on that particular thing.
set all these things. Right, I have to set all these things, then only I can.
Yeah, yes, yes.
Yeah, thank you, sir.
Correct. Yeah. And
Thank
also you have to give the output format, like you want it in a JSON format, or you want it in a list format, whatever the format you want, you have to
Kind of
provide it.
format we have to-
And also you have to provide some sample examples, so that it can understand your expectation, what exactly you are asking.
Okay, sir. Thanks a lot.
Okay. And also if you are working on working on images, you need to see which model is a multimodal model, it can accept like a text, both text as well as the image. You need to check with that, ma'am. Gemini models like Gemini Pro, it's a multimodal model. You can provide image as well as the text. Okay, it will
Other
yeah.
traits also.
For example, GPT-3 or GPT 3.5, it is not a multimodal thing. Okay, it accepts only text, and it will provide you only the text response. And whatever I have said, those Gemini models, Gemini Pro and Gemini 1.5 Flash, these are the multimodal models. It can accept speech, image, text, all kinds of inputs, but the output, it can provide the output in only in the form of text. Okay, it will these models will not generate the images. It can
Okay.
input is multimodal, but output is text in those models.
Yeah.
You need to properly see, suppose you want to generate the images. Okay, like suppose you want to synthesize, given an image, you want to generate synthetic images like 10 or 15 images based on that particular image. Okay, then you need to check with the models which, okay, from which you can generate synthetic images. Okay. Coming to cell 8. Okay, here we create a model instance. Okay, there is a class called chat open AI. We are creating the object of this particular class. Okay, while creating the object, we provide some inputs like model name. GPT-4 is the model name. Okay, and we are providing the OpenAI API key. Whatever we have stored above, we are storing we are providing input to this particular chat OpenAI. What I mean by this is not a function, this is the class chat OpenAI. Okay, while creating the object, we are passing some parameters, means it will while creating the object, it will call the constructors. Okay, and initialize these particular values. Okay, init function. Basically in init function we write um, statements to initialize some of the parameters. Okay, next, see here, we want to, whatever the object we have created, model object, we have we are testing here basically. Okay, model.invoke will call that particular API. Okay, GPT-4 API with this particular input. Who is the Prime Minister of India? This is the question. Okay, and we are providing it to model.invoke function. Okay, invoke function is there in the class chat OpenAI. Okay, we are calling through this particular object model. Okay, and if you display result.content, it will you can see the answer provided by this particular model GPT-4. Okay, next you can go to agent 1, ma'am. This agent 1 is for generating the discharge summary. Okay, so here you can see, ma'am, like you have asked that question, right? How to write a prompt, what how, like here is the template. Like this, you need to write the template. Okay, here first we are defining the function, okay, which takes doctor's notes. Okay. Now here is the prompt template. What you are saying, you are a medical expert. Convert the following doctor's note into a detailed and professional discharge summary. Okay. Think logically step by step. You have to give chain of thoughts here. The first thing what you are expected to do from LLM is like consider the given doctor's note and convert it into a detailed and professional discharge summary. Second one, provide the confidence score along with the discharge summary. You need to have whatever it provides the discharge summary. You need to how confident this particular LLM is to generate this particular summary. Okay, that confidence score it will generate. And the third one is output the result in below JSON format. You are providing the um, format also here. Okay, it has to provide it in a JSON format. Okay, a doctor's note. I have not provided here it. Okay, you can provide the example there. Okay, doctors.
Sir, please proceed, sir.
Yeah. Okay. Next, you are asking for the discharge summary here in the prompt. Okay, and notes will take whatever in the curly bracket you are providing notes, it will be replaced by the actual notes. Okay, this is the Python variable. Okay, we are using the F string basically. Okay, now in the try block, you can see model will take this particular prompt template as the input. Okay, and it will provide you the results, and you are returning that particular results dot contains. Okay, this is the function we are writing. First, to create any agent, first we need to write the function. Okay, little go below, ma'am. Little up. Can you scroll, ma'am? Scroll, ma'am.
Yes, sir.
Okay. In agent one only, ma'am. I want to see the complete cell. Okay, yeah, it looks fine now. Okay, now you can see you have written the function. You have written a function generate discharge summary. Now you need to create a agent. Okay, you need to create a agent. So to create the agent, you use tool. Okay, tool class. Okay, in that tool class you can see there are three parameters: name, function, and description. Okay, what is the you have to give the you have to provide the name of the agent, discharge summary agent. This is the name of the agent. Function is generate discharge summary. Okay, you can see the above function name. Okay, above function is generate underscore discharge underscore summary that you are providing it here. Okay, the same name you have to provide it here. It means it is utilizing your function. Okay, next, description. What this description is very important. Whatever the orchestrator function you have, okay, where it gets the input, by seeing this particular description, it will redirect to this particular agent. Okay, you can see the description, provide detailed discharge summary for a given doctor's note. Okay, as your orchestrator function knows, or sorry, orchestrator agent knows, this particular agent will provide the detailed discharge summary given a doctor's note. So this description is very important. If you keep this blank, okay, even though you are asking your orchestrator agent to provide the discharge summary, it will not provide that. It will not go to this particular tool. Okay, so this description is very, very important. These three fields are mandatory, and you have to provide the proper information in these particular three fields. Okay, this is what our first agent is. Now we will go to agent 2. Quickly we can go to agent 2, ma'am.
Yes, sir.
Agent 2 is a Wikipedia agent. Okay, here you can see there is a Wikipedia API wrapper class. Okay, we create the object. Okay, and then we create a tool. Okay, the name is Wikipedia medical search agent. That's the name. Function we use is wikipedia.run. Okay, description we give it as a useful for retrieving medical information about diseases, drugs, and treatments. Okay, this is what the description we have given. Next, agent 3. Agent 3 is for the symptom checker. Okay, we provide the prompt. We create the prompt template first. Input variable is symptoms. Template we are giving, you are a medical assistant based on the following symptoms, list possible conditions or illness. Like this we write the prompt. Okay, provide it in a template, and then we create a LLM chain, and followed by the yeah, agent creation. Okay, we create a tool, basically a symptom tool. Okay, this is for the agent 3. Okay, now the fourth one is very important. Initialize conversational agent. This is the orchestrator agent. This orchestrator is very important. Okay, here we need to bind all our tools. Okay, we need to bind our model. We need to bind our memory. Okay, you are creating a memory here to store the chat history to retain the context. Okay, you can see the first statement, memory equals to conversation buffer window memory. Okay, you are giving some name chat underscore history for that particular memory. Okay, and k equals to 3 means it has to remember past 3 conversations. If you want to remember past 1000 conversations, you just change this value to 1000. K equals to 1000. Okay, return message equals to true means we can access those particular information. Next, you can see initialize underscore agent. This is to create the orchestrator agent. Okay, here which type of agent we are using? Chat conversation react description means we are using react agent. There are multiple types of agents like react agent, reflection agent. Okay, like this there are many different types of agents based on uh, its particular functionality. Okay, next, here you can see tools. Okay, tools equals to in list we are providing the list of agents which we have created. Okay, discharge underscore summary underscore agent, this is the first agent we have created. Second agent is Wikipedia underscore tool. Third agent is symptom underscore tool. These are the list of tools. Suppose you have created 3 agents and you have given you have listed only 2 agents. For example, discharge summary agent, Wikipedia agent, Wikipedia tool. These two you have noted down here, but symptom underscore tool you will not write it in this particular list. Then it will not call your symptom underscore tool agent. It is mandatory to provide all the agent names in this particular list. Okay, otherwise it will not consider your particular agent, which you have missed it here. Okay, next, LLM equals to model. Okay, that model instance whatever you have created in the above cell which I have shown, that model variable you have to provide. Verbose equals to true means it will print the logs during the execution, like which agent it is calling. Okay, uh, uh, all these information. And max iteration is 3. Okay, okay, next, maximum iteration equals to 3. Like it has to how many times it has to loop through to get the proper response. Okay, now uh, uh, like agentic workflow. Here the name of this particular workflow is conversational underscore agent. For this you provide the prompt. Okay, you can see the prompt like provide the discharge summary. It's a doctor's note. Okay, now we are able to see the we will see only one output here. You can understand rest of the things. Okay, see here, for this particular prompt. Okay, for this particular prompt you can see action is discharge summary agent. You can see the output. Okay, it is redirecting to discharge summary agent, and action input it is providing it as the doctor's note. Okay, next what it will do, this particular discharge summary agent has provided the output here like admission details, treatment provided, discharge instructions, and also confidence score it has provided. You can just you can little go up, ma'am. Now whatever the discharge summary agent is there, that particular output you can see. Can you go a little up now? Sorry. Below. Okay, so here action equals to final answer. Okay, this particular JSON is returned by your discharge summary agent. This is the final answer it is providing. Action input, what is the action input? Whatever the summary it has generated, that will be the action input. The patient was admitted to the hospital due to severe abdominal, whatever it is it has generated. This is the final answer. Okay, now as we have written early stopping. As soon as it gets the answer, it will it will treat it as a final answer. Suppose you want to have some 3 iterations, compulsorily 3 iteration, then action will be to reiterate that. It will redirect to that particular agent again, okay, and that will refine that particular output. Okay, so this is how this agent works. Okay, similarly, anyway, you have this particular notebook. You can test these particular cases later. Okay, you can ask different questions also. You see how it behaves. Yes, ma'am. This and also like with respect to Gradio, if you want to, this is a backend code basically. If you want to like test it on the user interface, I have given a code, Gradio code below, ma'am. Slide, sorry, cell 18.
Yes, yes.
Okay, here is the Gradio code. Okay, so you can see below with gr.blocks as a demo. Okay, Gradio interface setup. Okay, so here you have to create the text box. Okay, text box to get the like to read the user input, and it has a button, submit button. You need to create the submit button. Okay, after clicking the submit underscore button value will be 1. Okay, and chat history, whatever the chat history is there, to show that again we have the text box. Okay, and the last statement, submit underscore button dot click. After clicking, it has to go to respond function. What respond function will do, it will take the user input, and then it will get the response. Okay, and it will uh, uh, it will show you show that particular response on the chat underscore history text box. Okay, yeah, if you want to like launch this particular framework, then you have demo.launch. Okay, it will give you the URL. Okay, public URL. Okay, when I say public URL, as long as this particular notebook is running, if you give this particular link to anybody, okay, it works in their system. It's a public URL. Okay, as this particular URL is running, you can test it in your system. You can check. Okay, and this share link expires in 1 week. Okay, but if you as long as this particular basically this notebook is running, okay, if you close this particular notebook, then you will not see that particular user interface and the functionalities. Okay, okay, this is the end of the session. Okay, if you have any question, you can ask me.
Participants, kindly ask any questions if you have. Participants, do you have any questions? So shall we proceed on to the next session? Sir, thank you so much, sir. It was really a very wonderful session, and you have explained the concepts as well, the theoretical part as well as the demonstration was too good. Thank you so much for the session and the time, sir. Really, we are, yeah, just thank you so much for giving your time as well. The presentation and the content was too good. It was useful as well. Thank you, sir. Sir, and one more information, we have validatory after the session by 6:30. Please join, sir. The same link only.
Sure, sure.
Okay, sir. Thank you so much, sir. Thank you.